And another DraftScience video presentation. So I think I will talk about gravity some, because D. Hilster is supposed to be doing that tomorrow. And I'm sure there won't be much use to the conversation that he has, because it really won't be in any kind of structure. He'll just have himself pose his crap. It'll be incomplete, and it won't account for actual things that exist in the universe and the consequences. It'll be too superficial, and it won't get to the real argument. Is there's an existing theory by conventional physics that's absolutely silly. Okay, the relativity, space-time, whatever kind of model that where you just label gravity. You don't really describe it or explain it. You just label it. You just call it bent space. You label a phenomenon. You don't explain why, what causes it, how it causes it, no mechanism. Just a magical energy force that causes things to move. Period. It's not really physics in any sense. It's not mechanical. And so we write that off, and then we just start with what actually happens. And what do you have to account for? And that's the part that nobody deals with. Well, what do you just have to account for? What's the actual effect? What is the actual event? And what can you say about it? And I've pointed out some obvious things, that it moves the same speed as the other forces, which clearly indicates it's a force. That's certainly something on its side. It's certainly something saying it's just as real as the other forces that cause momentum, like light and magnetism. You can't just pretend it away like it's some bent thing. You can't just label it away. And the other thing that's really important is that it's obviously happening to the smallest little bits. It's not happening to big objects. Like this gravity is happening to a big object. No, it's happening to the atoms, and more specifically, it's happening to the electrons and the protons. They're behaving, based on the existence of this circumstance of gravity. That gravity is a circumstance. It's a phenomenon. It's not a thing. It's an event, just like light. But anyway, so I'll get to that first, and then I'll do some comments, I guess. And some of the comments are vaguely related, I hope, and so some of that will be taken care of in the proceedings. So some of this is basic. So the first point to make is get rid of the stupid, silly GPS arguments, and because all that means, right? I mean, the GPS argument is just telling you that if you had a radioactive element that you're using as a clock, that all clocks will break in a different way, right? You can break a sand dial by turning it sideways. You can break a sundial by just putting shade. You can break clocks in a lot of ways. Pendulum clock, just stop the pendulum. Lots of ways, turn it a little bit crooked. Lots of ways to break clocks. And radioactive isotope thingy, when you're using something radioactive, as your clock, what we found, what the evidence suggests is that, this stuff doesn't like to be moved. It also doesn't like to be crowded. So we know that the time, how often one of these little isotopes pops out, how often the splitting of the atom takes place, or however we're measuring it, the radioactivity seeps out of the element. Well, the more crowded I make it, the quicker it accelerates, the quicker it would do its timing interval. So I can speed it up by heating it, I can speed it up by crowding it with a lot of atoms, and I can also change it. I can slow down the decay rate. I can make it decay less if I give it velocity. So if I put it in a circumstance where it's moving, it decays less. And I've suggested that simple explanation could just be that the way it decays is based on environmental circumstances, so environment matters, and what the environments are indicating, like the crowded environment is indicating that the more it gets hit with certain stuff, the more likely it is to decay. And so decay could simply mean that an event has to happen where it gets hit from two sides at exactly the same moment, and that'll cause the atom to decay. And if I was moving an object, then you could understand how it's not as likely to happen, because now I'm hitting more stuff coming one way and I'm hitting less stuff going the other way. So the odds of a simultaneous event are reduced with motion. And the more I speed it up, the more I reduce the odds of a simultaneous event. So that would be perfectly consistent. It would explain the broken clocks. And the other evidence for is just almost non-existent. I mean, all the evidence for relativity, the time dilation, the existence of a time dimension, or any of that crap, is really just based on clocks and how well they function, how much you can depend on them. And the simple argument is all the results that are confirming relativity can also be explained as just breaking clocks. They don't have any explicit evidence in any other case. They've never done light bending experiments or any other experiment that indicates any, where you could prove this case. And then you can go into all the arguments where, all the paradox arguments about the idea that all motion is relative, when we know that it's a fact that one of the twins, if I do the twin experiment, either the planet moves and the spaceship stays still, or the spaceship moves and the planet stays still. You can't have it both ways. So one of them is actually moving and one of them doesn't move, and that's the only way it can work. There's no perception argument. Either one ages faster and one doesn't age as fast. And again, the idea that we can equate the fact that you can delay radioactive decay to physical metabolism, that somehow our physical metabolism would slow down the same way our decay rate slows down, we have no reason to believe that. So there's no reason, we can't really do any aging experiments to verify this fact that this even takes place. And all it would be called would be cryogenics if it did. It's just basically putting you to sleep. You're not living longer, you're just living slower. And the rest of the universe is speeding by at incredible speeds if you're going these incredible speeds. And you could see that just by opening a window. So the whole relativity thing is just dependent on all these little closed thought experiments in a universe that shouldn't exist anyway. There's no universe. I mean, we can build spaceships with windows in them. So we don't have to play these games. But anyway, so it's really a bad theory. Bent space-time is just a really bad theory for a lot of reasons, but mostly because it's completely unevidenced, with any direct evidence. So anyway, so gravity is just this idea that two things end up attracting each other, in space. And, the simple argument would be that somehow, if you understand, like if you were to have a force, no matter what it would be, of something that carried momentum, you'd know that, everything in space would be its own object, and frankly it has to reach a kind of thermal equilibrium. That is, as much energy has to go in as comes out, or the thing has to get bigger, or it has to do something. The energy can't just disappear. So if as much goes in as it goes out, you can't really create gravity, right? You can't create a circumstance where there's an outside pressure that's higher, than this low pressure somewhere else. You can't really create that without in some way consuming the energy. So it has to go somewhere. And so that's the problem. Is there's no theory for the destruction of energy. And if you use just a Lesage simplification, you're going to run into these problems because, as a simplification, you just say, well, more stuff, is out here, and some of the stuff gets blocked, in here, and so there's less stuff coming out here, and, and vice versa. I mean, I should have drawn it the other way, like this has more gravity, but the idea would be there's more stuff going here, the stuff gets blocked by the object, so less stuff comes out of here, so there's more stuff here than is going this way, so the object moves into that deficit. But to do all that, you have to explain where the energy went. I mean, where is it? And so you sort of can explain it just as a delay if you understand that all the movement of little bits inside of something has to constantly be maintained. That you can't just You can't just have it go in, heat it up, and then once it's heated, you don't use up any energy anymore. You know, that there is a real thermal equilibrium. So anyway, I have proposed a simple solution to that part of the problem. Is just that the fact is that the electrons and protons that the thing is made out of are what are really capturing the force. So the force is going in, but what it's doing is if it doesn't hit anything, well then it goes straight through and it moves the speed of light. But if it hits something and pushes it for a little bit until it hits an opposite force, you know, something hits the opposite way and it's now released, there's a reflection and the force can go about its way. But any time spent pushing the matter, it's moving the matter slower than the speed of light. The electron doesn't go as fast as light when it gets hit by just one little bit of force. It goes like maybe 10% or 5%. If it gets hit by another one, then, you know, then it can go 20% and then 30% and blah 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 blah. So anyway, the idea is how much did this piece of force, how much time did it spend pushing matter versus freely flying? And the truth would be is it's going to be something less than c. So if it pushes matter, it's going to travel from here to here at less than the speed of light. And that means if you add up its momentum, you know, its mass times its velocity, you're going to get a number that's going to be lower. So it lost momentum. For the period of time it was moving matter, it had less momentum than it would if it didn't hit anything. And it's just sort of a truth. And so the energy in a sense was used. Now the matter's moving, which is the trade-off. The thing you get is a secondary effect, but the matter moving isn't exactly the same as the force. So anyway, so the point is that the Earth is doing this in all directions. You're moving little electrons and protons, and every time you move one, you're stealing a little bit of the universe's energy, and that's what's creating gravity. So that's what's causing there to be more force out here, because it's moving the speed of light, and the force coming this way is a little less than the speed of light because it lost a little momentum going through the Earth. So that would be the simple logic to explain why there's this differential between the pressure out here and the pressure going this way. So the pressure this way is less than the pressure this way, then the overall effect is going to be more electrons will be hit going this way than getting hit going that way, and the object's going to inevitably move this way. Now, the thing that makes this, you know, there's always subtleties to, you know, it'd be nice if the universe was this simple, but there's always catches, and one of the catches is drag. And related to that, though, is the catch between the difference between accelerating something, that is causing something to move from one place to another, you know, hitting it, acceleration, and velocity, which seems to be a function of something that's permanent. Velocity seems to be something that doesn't need energy. Once you have it, then you have it. You've collected it. You're doing it. It's velocity. So I've pointed out that the experimental evidence sort of indicates that electrons and protons don't get permanent velocity, that their velocity runs out. If you shoot some in space, they don't go forever. There's a point where they are dragged to a halt, and they're just, you know, they can only collect so much energy, like a gamma ray behind them, and as they run into more energy, as they're moving into the field of energy, they're going to hit more of it. If I move my hand forward, it's going to hit more photons going that way, you know, towards me, than photons going with my direction. And it's just a fact. More photons will hit the palm of my hand than the back of my hand. And the same thing happens to an electron. When it moves into the force, it's hitting more force, and that ends up just reflecting this extra energy it had pushing it, ends up getting lost because there's less energy helping, there's less helping wind and more opposing wind, so this energy gets lost and the electron has a finite ability to keep going, depending on how much energy I put behind it, how many bits of energy I've stacked up behind it at a tight, narrow frequency. So electrons theoretically can only be pushed by photons that have a very high frequency. Anyway, but the point is if you can accept that as a truth, that there really isn't any experimental evidence of the the electron that we shot from the space shuttle and it landed on the moon, or even that we shot from the space shuttle and it landed in a satellite a few hundred miles away. There's no evidence that we can shoot electrons that far, that we can push them that far. So electrons and protons don't have permanent velocity. They always just have acceleration, in the sense that they're being actively forced to move. Now the other trick would be, like, if the gravitational theory, okay, of a particle theory, then you would also have the consequence, not only the drag consequence, that is, as you have velocity, you'd be moving into more force and it would take away your energy. But the fact is, the Earth overcomes that all every day, right? I mean, it's constantly moving around the sun, we know that, and it doesn't lose velocity. And so there has to be an explanation if you're going to keep a particle theory, because it has to be running into more force. It has to. Just can't evade it. And the trick is that once you make atoms, helium especially, what they found is that the only stuff in space that gets to us in the form of cosmic radiation that has any substance to it are helium nucleuses. That is, nucleuses that have electrons and protons in them. They're more complex than just an electron or a single proton. They're a combination. And that combination has the power to create a little motor that works against that extra force. So if I made a simple device, where there's a simple rule, the force goes from the electron, and when it goes into the proton it turns 90 degrees, and it bounces off the electron, and then it turns 90 degrees and it bounces off the electron. If I make that simple device where there's a ping pong ball, and this is a paddle and this is a paddle, and the thing in the middle just turns at 90 degrees, just a mirror, you could sort of understand that if the ping pong ball had perpetual energy, that is, it doesn't run out of energy, that it would just keep bouncing between these two objects. And in a sense, the more I pushed on these electrons, the tighter they got, the more energy they would have pushing back. So if there was 10 of them and they're bouncing back and forth, you could, just one, you understand the less distance there is, the more often it hits. And hitting is always the same. So there's nothing like, I can't lessen the hits. I can't lessen the impact by hitting more often. It's always the same amount of force I hit with, no matter how fast I hit. So each hit is really just momentum. And so you can understand that when they're far away, the electrons, it's very long time before you get a hit, and that means that the force hitting against it is going to have more capacity to compress it. But the more it compresses it, the faster it responds in terms of pushing back. So you can see how this, in theory, would explain how atoms with nucleuses that have neutrons and protons and electrons. Well, the neutron is a proton and electron. That's another part of the story that you should understand. But anyway, that you could arrange electrons and protons in such a manner where they do have a bias in a direction. And that if you do push on them, they'll push back, in the sense that you'll create more energy. Essentially, energy is hitting something. You'll have more contact between the objects, and that will perfectly compensate for any increase in the wind. So as the wind pushes against me, I have a spring kind of mechanism that pushes back, and in effect, and it's going to end up saying that yes, you'll always have motion in this direction. So it can, in the nucleus, you could argue that these little objects already exist, and they have a bias based on how much pressure they're under, and you can change where they're going. So in the nucleus, they could be just spinning around in a circle, and you can understand that they're moving in a circle, or it can be an oblong circle, and then that would give them motion in a direction. So you can just understand by just changing how I position them, how much time they spend going in one direction versus the direction they're going. The whole system is moving in a direction based on the fact that they're moving in that direction, and then they just cycle around the other side faster than they pushed, and that means they'll constantly be going in a direction. So I can trap the energy, and I can trap it in such a way where I can, just by changing the orbit, I can change the direction that the thing would be moving. And the more I change the orbit, that is, the more I compress the atom, the nucleus more specifically, the more I compress it, the more pressure it puts in a direction that it's pointed, so to speak. It's always pointed in a direction then, and it'll go in that direction. So anyway, so the key point is, the key takeaway is this is velocity, all right, and this is acceleration. So the force acting on the little bits is acceleration. When it acts on the little bits, it causes motion. The motion causes an increase in pressure. The increase in pressure creates a response by the motor, and so that's the velocity part. So it's, the two are connected, but they're two different functions. That's why when you're trying to accelerate a physical object with matter, the reason why you can't do it with perfect efficiency, it doesn't automatically, as soon as you hit it with the force, it doesn't move at that speed. The reason why it takes time to accelerate is because it takes time to remove, to reshape these nuclei. By adding more pressure in this direction, you're reshaping it. That is, you're bending this up a little and bending this down a little. You're changing the shape a little. By changing the shape a little, you're increasing the efficiency, let's say, of the spring. So I just wanted to make that distinction, that the reason why, the implication of gravity that you have to explain if you're going to use a particle model is not only the fact that you have to be able to overcome drag, but you're overcoming, like in the example of the sun and the earth is moving in a direction. Well, you would argue as it's moving in a direction, it's creating gravity, because on this side it's going to get hit with more force, and on this side it's going to get hit by less force. So the force it's going into, it's going to get more of that. It's going to get less push from behind. So as it goes around this way, you would have to argue that it should be more gravity in front, from on this side. If you don't happen to be on this side of the earth at the moment, right, in terms of the spin of the earth and the position of it as it's moving around, you should be feeling, the effect of being on the leading edge, the front end of the earth. And when you're on the back side of the earth, there should be a difference in the gravity. But the real trick is that doesn't happen because the Earth's velocity, negated that differential. The velocity is different than acceleration from gravity. So it's not subject to the same effect because of the fact that this velocity wasn't generated by absorbing force. You didn't absorb force from the external world to have this velocity. So unlike an electron getting moved, you didn't hit electrons with force and use up their energy. You're using the energy you've already trapped. You're using a piece that's already stuck inside the nucleus. That is creating more and less energy by compressing and relaxing. So you're not pulling the energy out of the environment, so you wouldn't feel more gravity, because the fact is you didn't absorb more energy coming from behind you, and therefore, because the velocity was already inside of you, so by not absorbing more energy, you're not going to create this differential. So that would be the explanation. And you're also not destroying the energy, because as like I said, you're creating a rebound balance. Now the truth is there probably should be a little bit more gravity on the front edge. It still should be a little bit more pressure, but the Earth just isn't going quite fast enough to create enough of a difference. All right, so is there anything else? I've already kind of explained a lot of this stuff. The point is we're sort of just bouncing in gravity, and you never feel gravity. So that's part of Einstein's relativity. He does these thought experiments based on you falling inside of elevators or spaceships and what we feel. It's not about what you feel, because every time gravity moves you, even if gravity was moving you at the speed of light, you wouldn't feel it, because gravity affects all of you at the same time, effectively. Its effects are so fast and so even that you don't feel it, because part of your body doesn't move at different speeds. When somebody pushes you, they're pushing one part of you at a time, and you feel it because there's more pressure in one spot than there is in other spots. They're not moving at the same speed. And so it's the only time you feel motion is when the motion is uneven, that it's coming in through your feet, for example, or it comes in through a fist, punched into your face, and that's when you feel motion. But you're not going to feel it if something moves all of your bits exactly the same amount at exactly almost the same time, so you can't even tell the difference. That wind you can't feel. The wind that blows your electrons and protons you won't feel. You can only feel the winds that are blowing pieces of you unevenly. So that's why people have this illusion that they're feeling gravity. You're not feeling gravity. You're feeling the earth pushing you back. That's the only part you're feeling. That's the only part that you sense, is the impact with the earth, and the earth pushing, actually physically pushing back. So we're constantly moving on the surface of the earth, in the sense that pieces of us are being pushed down by gravity. They're hitting the earth. The earth is pushing back on pieces and pushing them back up. So we're essentially bouncing on the surface of the earth. And that's why the clocks on the earth are running slower than the satellites. Now, even though the satellites going 22,000 miles an hour, some of them are going pretty fast, even though it's going really fast, it's not bouncing as much as us because it's in weaker gravity, so it's bouncing slower. So you can understand that this is going to be more distance because it's a lot of up and downs. This is a lot more distance than this. I mean, the distance I travel on the surface of the earth is almost irrelevant to my total velocity. My total velocity is how much up and downing I did. So it's like the velocity of a basketball isn't the velocity of the basketball player. The basketball is moving a lot faster than the player's moving because the basketball's doing all this extra motion as it goes forward. So this is why the clocks on Earth are moving slower, is because the clocks on Earth are actually moving in real space a lot more distance in the same amount of time than the satellite. Even though the satellite's going, we're only going a couple of thousand miles an hour, and the satellite's going a lot faster. We're going 22 miles an hour. So even though we're going really, well, no, it's not 22. The Earth is circulating, well, I can't remember the number, so it doesn't matter. Even if we were, let's just say 2,000 miles an hour. Well, it's not 2,000 because it's only 40,000 all the way around. So let's just say 68 miles an hour. I don't know how many miles an hour it is. Anyway, we're moving a certain speed, on the orbiting Earth, on the rotating Earth. That's much slower, but we're bouncing a lot more because we're in a lot heavier gravity. Alright. So this is all explainable, and you can have rational conversations based on rational premises, or you can just do this silly, let's just label stuff and pretend I can just say the word GPS and I proved Einstein's theory. I proved it's bent space that's causing the effect when it doesn't have anything to do with bent space. It has to do with the fact that clocks break. They change their standard. It's breaking is the only way to say it, right? I mean, the clock's broken if 1 second isn't 1 second anymore. What used to happen in 1 second, if I change how big the hole is on the sand dial, I've changed the clock, right? If it was doing a certain amount of sand in 1 second and I change how much sand falls in 1 second, I've essentially broken the sand dial, And the same thing happens to other material objects when you do things like move them with velocity. Alright, so now comments. Alright, I can't wait till, so I read part of this before, and then the guy says, Captain Grubb, I wonder how Mendham would react to Eric Weinstein. I suspect he would expose Eric's bullshit. Well, actually, half his argument is really quite valid, that conventional physics is very unfinished, incomplete. The answers aren't well established as well proven. And so that part of his argument is good. And yes, I realize Weinstein is not a physicist. So later he's going to say that Weinstein said, I have a theory, and then didn't show it. I think he has shown what his theory is, just more convoluted nonsense. So the irony is, like 6 years ago, he did some sort of video where he was basically outing conventional physics as being, pretty full of shit, without an explanation. He's just sort of saying we need to redo this Einstein thing. We need a better starting point because bent space and quantum mechanics really don't fit together, and they really can't be part of the same rational theory of reality, because it just doesn't fit. So I don't, I can't say that he promised to reveal a theory and then didn't reveal it. So I didn't see that video. So you have to show me a link to that, because I haven't seen him do that. But what I have seen him do is present a theory that's like quantum color crap or something. Some sort of bizarre, 50 zillion moving parts, neutrinos, all of that crap still exists, entanglement. He keeps all the bad parts of physics, because he thinks those are somehow the reality, and that's just the mush. Alright, so now this guy, Crimson Ways, he did this twice. He posted the same damn comment twice. Can you explain the formation development of stellar explosions, supernova, and the like? Well, yeah, I have done that, and I did it to this comment. And so it's almost like I've made it so clear that I think the big universe is really uninteresting. There's only one universe. It's the small universe. It causes all of these other manifestations of matter, and the big stuff is really doing kind of crude and simple things, even the way it evolves into explosions and such. So I gave you a simple explanation. Apparently it's not good enough. Stars age. As they're producing helium, they end up producing all these other elements too. Not a whole bunch, but maybe 20 or 30 of the periodic table, up to like carbon or something. So they're producing nucleuses, essentially, okay? Heavier and heavier combinations. And that heavy stuff doesn't go anywhere except sink into the sun. And so the pressure inside the sun is going to start increasing as the density increases. So even though you're burning stuff, you're also collecting stuff at probably the same rate you're burning it. So the sun ends up getting heavy in the center, and it's almost like building a pipe bomb. You have incredible pressures, and then you could probably create a layer of like these heavy elements. And the fact is the pressure gets too great and it leaks. It finds a fissure and it shoots out through a crack, and that crack becomes the explosion. Okay, so it's like a balloon bursting or some other kind of thing. It happens. Now there aren't that many supernovas, right? It's only one per galaxy per year or something. So it's not like it's the most common event, and I guess it just happens because there's some irregularity, like maybe Saturn and Jupiter line up and that creates a fissure and the sun explodes, that kind of thing. But I say the bottom line is, who cares? If you think looking at that crap is going to tell you what the little tiny electrons and protons are doing, I just think you're missing the obvious. Understanding this is going to tell you what they're doing. Okay, understanding supernovas, no, that's not going to tell you. So I have answered this like 3 times now, but whatever. I'm deleting it because it's annoying to repost the same comment. Alright, then Captain Grub. And this is just so badly written that I can't do much with it. And there it is. Okay, so he's doing the time code thing, which is pretty annoying. That is right where you can know, if one didn't know already, that he's full of it. Okay, so he's talking about Robert Ritchie's infinite energy proposal, whatever you want to call it, free energy, gravitational engine, magic, or whatever. And the fact is, as soon as somebody starts promising, oh yeah, tomorrow I'll show you how it works, yeah, tomorrow never shows up. I mentioned Eric Weinstein on the other video comment, and that's just what he did as well. See, I don't really think he did, but whatever. He proposed a revolutionary idea. No, he first proposed that there should be a revolution, that they need a revolution, that they need a Castro. They need somebody to lead the revolution. Physics is desperate for somebody rational, because, the physics has gotten irrational. A revolution idea in physics, but then said he has to hold off revealing it in full for now. Well, whenever. I didn't see that statement, so you have to show me where he said he's holding off. And at first he didn't have an idea, and the fact that he's developed some notion of one, yes, I would argue it's a pretty superficial in terms of it's not really going to get to all the experimental evidence, and it's not going to be an explanation that has any of these, that he can make it consistent with the facts. Because it's bullshit. It's made out of all these bullshit notions that entanglement is real, that interference is real, that interferometers really work. All that kind of crap is built into his notions. Alright, so then the captain says, I was going to ask Gary about the 1919 eclipse thing, so much for that one. Well, good, I'm glad you've heard the explanation. The 18 experiment's never been repeated with better technology, in spite of the fact that from space, it's 400 times easier to see. 400 times. Never done from space. Also, the atomic clock, he straightened that one out too. Well, then why are you going to bother with the GPS comment later? It's exactly the same argument. Anyway, what about the detection of gravitational waves with mirrors? It's bouncing the same beam, right? They sort of give you this impression that they made the thing 2 miles long because, 2 miles is a good distance, and, we'll do it after 2 miles. No, they're bouncing it back and forth 800 times, so they're traveling 1,600 miles or something. But yes, 800 times through a mirror, and we're supposed to believe, no problem. That doesn't mess up your results any. I know he's probably addressed it, but I just watched my first 10 hours of DraftScience in 3 days, so cut me a break. Well, whatever. But yes, I have been over and over it. And finally, what about the apparent functional utility? So that's the idea that's funny. If they never heard the theory of relativity, they would have noticed that clocks run differently on satellites. It's a little tiny difference, but they would have figured that out. That they didn't need relativity to tell them. They actually found out by the fact that they said, hey, it's funny, the clock's off. How'd the clock get off? Well, who cares how it got off? Fix it. And so that's all they did, right? And then, it became an idea that GPS, when GPS first came out, nobody said, oh, this is a proof of Einstein's theory. Now, that came later, At first, they just dealt with the fact that, this satellites, it fucks up the clock. Anyway, utility of accepted physics. So, again, it's the whole thing is really quite deceptive in the sense that the clocks on the satellites are actually running too fast. We're the ones with the slow clocks. The ones on the ground are the ones moving too slowly. All right. For example, that is often pointed out that the GPS in our phones only works because of an application of general relativity. So again, you never even need to hear about it to figure out, well, there's something about the satellites. Either the gravity or their velocity is fucking up the clocks. And again, the first notion would be that their velocity is what's fucking them up, right? But it's not their velocity in a direction, it's their velocity in gravity. They're moving less in gravity, and we're moving more in gravity. And it's the gravity, it's the motion from gravity that's actually causing the clock to break. And you could argue it's the one on the ground that's more broken. Which is the funny part, the ironic part. Alright, so I think I took care of that. So there was two. Where's the other one by the other guy? There it is. Can you describe how stellar explosions, supernova, and the like happen? So there it is again. It's really irritating. So I'm going to remove it because it's really irritating. Alright. some guy with his dude comment. Jeez. All right. Anyway, I mean, there's just there's no point in even talking to the Ken Wheeler sycophant retards. So that might be the next video, just because I found somebody linked me to another Ken Wheeler devotee doing some spinning magnet experiment based on Ken Wheeler's bullshit. And the video by Ken Wheeler is so fucking funny, in the sense he's pointing out how some phenomenon proves him wrong, but he won't do the experiment himself. So he builds a little coil with magnets and then says somebody else should do this. It's hilarious. It has wires coming off of it, like somehow, and he's making this assertion that, yeah, I can make your motor, 40 times more efficient. Oh, you can? And then why don't you do that? Oh, but no, that doesn't happen. So anyway, I think that's probably enough. Yeah, that's enough. I'll just say it's enough. Yeah. Alright, so till the next time and such, so forth and whatnot. So we'll see what the De-Hilster Club comes up with as a gravity. I'll watch it and I'll let you know maybe. But I'm sure it just won't get to what you have to describe. You have to describe a cause for one thing to move into another, and it has to be consistent with what the implications would be. So you can't just say they do it because they wanted to. Oh, there's an attractive force that makes it happen, the attraction thing. That's not an explanation. It's not. There's a reason the electron is sitting there saying, I'm sitting here in space. And there's a reason it's being obliged to move. And you have to explain what the reason is. Calling it bent space isn't explaining it. Not even close. You're just saying, oh, it's magical. Magic. Anyway, so till the next time and such, this has been a DraftScience video presentation.